6.3 angles and radian measures. A lot of what we're going to do today is, well, you have seen it before last year. We're going to get into a little bit of new stuff, which kind of physics, a little bit of physics. So here we go. It says, in trigonometry, we can think of an angle in a different way. An angle can be thought of as being formed by a rotating array around an endpoint or a vertex. The starting point is thought of as the initial side. The final position after the rotation is called the terminal side. Counterclockwise rotations are positive angles. Clockwise rotations are negative angles. An angle on the coordinate plane is said to be in standard position if it's in the. You can't hardly see these pictures on your notes, but if the vertex is at the origin, its initial side is the positive x-axis, and the terminal side is rotated from there. So let me explain, and it is hard to see here, but it's easy to explain. This is how we graph angles. Okay, this is how we draw pictures of angles. This is standard position when your initial side, and your initial side, from what I just read, that's your starting point. You start at your initial side, and the positive x-axis over here is what we're going to start as our initial side. Excuse me. If you rotate counterclockwise from there, those are positive angles. To where the y-axis, the positive y-axis will be 90 degrees, the negative x-axis will be 180 degrees, and we're talking about today angles bigger than 180. So that's we'll go on from there in just a second. Again, standard position, x-axis is your initial side, and your terminal side rotates from there. If you rotate in the opposite direction, if you rotate clockwise, I might have said counterclockwise is positive, clockwise is a negative angle. If you go down and then start rotating, that's a negative angle. Angles formed by different rotations that have the same initial and terminal side are referred to as coterminal angles. And again, let me explain what I mean by, first off, just angles in general. If I have an initial side along that positive x-axis, if I rotate up to the y-axis, that's a 90-degree angle. Okay, this is a positive angle. If I rotate it on around, if I rotate it to the, let me draw that back. If I rotate it on around to the negative x-axis and I had a straight line, we know that all straight lines are 180 degrees. If I rotate it on around to the negative y-axis down here, what angle measure would that be? That's positive 270 because we're still rotating in the positive direction. And then on around, even though it ends up in the same spot, if you rotate all the way around, that's a 360 degree angle. Okay, so that's what we're discussing today again, is angles bigger than 180. So 360, if you had two rotations, if you saw two circles there, that's right. How big would that be? A 720, and then three rotations, 1080 or whatever. Each rotation is 360 degrees. If we're going in the negative direction, if your arrow's like this, what would that be? Negative 90 degrees. So if you're rotating down, it's negative. Rotating up is positive. Angles formed by angles formed by different rotations that have the same initial side and terminal side are referred to as coterminal angles. Coterminal angles stop in the same spot. Let's look at examples of coterminal angles. If you've got let's call it a 45-degree angle. Okay, has an initial side along the x-axis, positive x-axis, and a terminal side at 45 degrees. That's going to be the same thing as, well, what if I rotated one full rotation and then go another 45 degrees? Those two angles are called coterminal angles because notice where their terminal sides are. Same place. Yeah. Coterminal. Co means together, with. Terminal is where it stops. It stops in the same spot. So 45 degrees is coterminal with, let's say we did 360 plus another 45 is 405 degrees. Those two angles would be the same thing. Makes sense what coterminal angles are. Somebody give me, let's say, a 90-degree angle. If I have a 90-degree angle, it's going to be that. What would be coterminal with 90 degrees? 450 degrees. That's a full rotation plus another 90 degrees. A 450-degree angle would be coterminal with 90. What negative angle is coterminal with 90? Negative 270. A positive 90 and a negative 270 is the same angle. Those would be coterminal because they stop in the same spot. Makes sense. Pretty much same angle. It says find three angles that are coterminal with an angle of 30 degrees in standard position. So 30 degrees is going to be about right here. So if I ask you to find three angles that are coterminal, the easy way of doing it, add rotations. A rotation is 360 degrees, so 360 degrees plus another 30, which would be 390 degrees, would be coterminal with 30. What would be another one? Negative 330 degrees, because that would be starting at 0 and going this direction. Would end up also at 30 degrees. And let's see, 570. Let's think about that one. Let me erase this. 570, you would go, that would be 360 plus another 110. That'd be over here. Or 210, no, plus another 210, so that would actually be down here somewhere. That makes sense. So you're going to have to add a full rotation. 750 degrees. 360s. Yeah. No, you add 360. Your angles start. If you a 360 degree angle is going to start here, and it's going to end up back here. But if you want it to end up back where the 30 degree angle is, you're going to take the 360 and add that other 30, which would be 390, which is how we got this. Yes, 360 plus where you want it to get to, because the 360 just brings you back to where you started, and then add 30 more to get to wherever you want to go. For 90, 360 plus 90, 450 degrees. That's right. That's right. So these three angles are coterminal with 30 degrees. Next section, radian measures. Everything that we've measured this far has been in degrees. Now we're going to start talking about radians. It says, in order to simplify some formulas in calculus and physics, sometimes we don't use degrees to measure angles. We use an alternate form of measuring angles, which are called radians. 1 radian is about 57.3 degrees. You don't have to know that. Radians are defined in terms of pi. Radians is the same. Pi radians is about the same thing as, or is the same thing as 180 degrees. We didn't talk about this last year, but let me explain something about what a radian is. If you have what's called a unit circle, why do they call it a unit circle? Does anybody tell me that? Unit. What's a unit? When you think about the word unit, it's a hole. It's one hole. They call it a unit circle because the radius is 1. Okay, if you took a unit circle and you took its circumference, can anybody tell me what the circumference of this would be? Circumference. What is circumference? The distance around a circle. Which would be, no, distance, not angles. Pi times diameter, what would that be? Pi times, what's the diameter of this? 2 times pi, 6.28 would be the radius of that. To where a radian has, hard to explain, a radian has somewhat, it's a relationship between the circumference and a radius. If you took this radius of 1 and you laid it out on the circumference of that circle, that would be 1 radian. But again, let's not go there for confusion purposes. That's fine. What you need to know: 180 degrees. Half a circle is pi radians. That's the biggest thing that you need to remember about radians. 180 degrees is pi radians. So 360 degrees would be 2 pi radians. So a complete circle contains 2 pi. It spins around 2 pi's. So 180 degrees, half a rotation is pi radians. 360 degrees, 2 pi radians. Yes, radians. 180 degrees equals 3.14 radians. And let's label that, because I'm glad you said that. So we've got, in terms of degrees, this is 0 degrees, and it's also 0 radians. This is 180 degrees, which is equal to 3.14 radians. 3.14159 radians. So 90 degrees would equal how many radians? Anybody tell me that? Half of 1.57. Half 30, and then half 14. And then therefore 270 degrees would be 90, and 180 is actually 4.71 radians. And back around 360 degrees, 6.28 radians. Any questions? So measuring something in radians, if I said 1 radian, what quadrant would you be in? 1 radian. 90 degrees is 1.57 radians. 0 degrees is 0 radians. So do you see that you'd be somewhere between 0 and 90? You'd be in quadrant 1. If I said 2 radians, what quadrant would 2 radians be in? The second quadrant. Because, again, 1.57 radians, 3.14 radians, 2 is between that. So 2 radians is in the second quadrant. 3 radians is also in the second quadrant. It's nearly 3.14. 4 radians would be in the third quadrant. 5 radians would be in the fourth quadrant. 6 radians would be in the fourth quadrant as well, because it's less than 6.28. So that's what a radian is. A radian is, it says 1 radian is about 57.3 degrees. But again, you don't have to know that. To convert to degrees, to convert to degrees, that should be from degrees. To convert from degrees to radians, we multiply by pi over 180. So if we have, let's do an easy one, 90 degrees. And we already know how many radians that is. So that's the reason I can do this. From chemistry, I think y'all had some of this in chemistry. If I wanted to get the degrees to cancel and I want to change this to radians, we're going to, y'all remember a while ago, pi is the same thing as 180. So what we're going to do, we're going to multiply times pi radians over 180 degrees. This is easy. This is easy. Watch it. The reason we do that, step 1, pi and 180 is the exact same thing, correct? So what are you technically multiplying by? 1. So it's legal. The degrees cancel. 90 and 180 cross cancel. Gives you a 1 and a 2. Correct? So what are you left with on top? Pi. On bottom you're left with 2. That is pi over 2 radians. Is that not the same thing we got a while ago? Pi over 2, half a pi, well, that's a half, that's it, it's half of a radian. 1 radian would be 180, so 90 would be half of a radian, yeah. If you wanted to, could you plug in 3.14 divided by 2? Sure, 1.57, that's what we got up here. 1.57. Okay. You could. Yeah, on that one. Like 60. 60 you can figure out. Because if use your common sense on these for the easier angles. If pi is 180, what's the relationship between 180 and 60? It's a third of it, right? 3 3/60 is 180. So if pi is 180, then you can divide that by 3 to give you 60. So 60 degrees would be pi over 3. Because pi is 180 degrees.